All right, welcome back from the break. I hope you were able to gather lunch or whatever it is that is relevant to the time zone you are currently in. We have just a handful of more talks for the remainder of today. I hope that you've got enough caffeine to get you through the next one, which is actually, funny enough, me. So I'm going to be joined by a coworker of mine, Karthikeyan. Hi, Karthik. How you
Hey,
doing?
hey Jesse, I'm good. How are you?
Doing good. So Karthik has got the far east time zone covered. I've got the middle of the world time zone covered, and we got some other people that are over on the west coast. So we got everything covered today. Representation in this talk, which is great. Let's go ahead and bring the slides online because we actually have a little bit where we introduce ourselves at that point. So we'll go ahead and get to there. But I'm going to go ahead and reset my little timer here for my slides so that I have awareness of how long we're taking. But yeah, so today's talk is streaming subscriptions in GraphQL, which sounds really cool. I think it is actually really cool, but we're going to go ahead and go into that. But before we go any further, we'll actually do the official introductions. I've been introduced before. So Karthik, why don't you tell everybody who you are, what it is you do?
Okay, sure. So my name is Karthikeyan, and I'm a software engineer at Hasura. So mostly I work with the eventing subsystem of the GraphQL engine we have, and the streaming subscription is something new I've been working on. I'm very excited to show it to you all.
Yeah, so like I get to put the words together, and Karthik is here to actually make sure I don't put the wrong words together, and to also validate and be able to explain just how much hard work's been going into this, because it is a really cool concept, and I think you're gonna like it. As far as where it is that we actually are coworkers together, we're both coworkers at Hasura. Hasura is a globally distributed company that is our primary product that you might be familiar with in the GraphQL space is GraphQL Engine. GraphQL Engine is a data API generator tool. You give it your data set, so you attach it. Typically, it used to be Postgres. Now it's a whole lot of things, but you give it a data set, and it will generate GraphQL APIs for you with authentication, with access controls, with permissions, with subscriptions, and everything you could want from GraphQL. And it's really pretty magical. It does everything you want. And they're kind of following with the method or the ethos of making data self-serve. So you have data, you have an access layer, and then you have your consumers. And that connection between the access layer and the consumer is GraphQL, and we generate those APIs for you automatically, as well as giving you access to things like some REST endpoints and other details. We've heard a lot about REST, about microservices and things like that. You can do that here. So,
Yeah. Hey
yeah,
Jesse,
you have
what
something to add?
about?
Mm-hmm.
Yeah, sure. So, if you're wondering if you already have a GraphQL service running for you and how do you move to Hasura, so you don't need to worry about it because if you have any GraphQL service running, you can stitch it with Hasura's GraphQL schema, so you don't have to abandon your existing GraphQL service. You can use it with Hasura. So that's pretty cool too, right?
That's a really important point. Yeah, stitching, not the right word because that's the bad word. but it's you can bring in remote schemas and actually create cross joins from your local data set to any GraphQL service. So any other service providers that we've been featuring today, you can use with Hasura using remote schemas. So yeah, absolutely. And we do support a lot of data sets. So this is the current stack of what we support. So as you can see, any GraphQL API mentioned there at the bottom. You can see REST APIs as well. The REST APIs we generate also are Open API compliant. And then you have the Postgres, the flavors of Postgres, SQL Server, and BigQuery now. And we're going to be dropping support here really quick for MySQL. And there's something like MongoDB, PlanetScale, other cool stuff are in the works at all times, picking up speed rapidly on the data front. Moving along, we then have basically, so the basic primitive of what Hasura does, and I just kind of want to give some context here because it's going to make some more sense later on in the demo we have at the end. But essentially, Hasura takes care of three specific pillars of your stack. It's the build layer, so it's actually generating the APIs. It's giving you the RBAC controls. It's giving you the custom business logic, triggers, event management, real-time APIs. It lets you do deploys, so it's got migrations. It's got version control. And we have our whole product is open source. So you have an open source version that you can either work with by itself, or you can use that as a deployment path to our cloud service with Hasura Cloud, which is a really fast way to get up and started. So really fantastic tooling. And then we have the management layer. So you've got analytics, you've got caching, you've got the ability to do observability inside of those API layers. So it's kind of these three pillars of what Hasura is solving for. And yeah, it's a really great data layer tool to work with. Like I said, fully open source. We got Docker images. We just released a preview of Mac ARM support yesterday, so now you can actually use it on M1s. Yeah, really cool stuff. So that brings us to the topic of today, which is specifically then what are subscriptions? Subscriptions are something that is part of the GraphQL spec, which we talked about at the beginning. It's one of those top 3 root level fields. But it's something that can be tricky because, again, being a specification, it is not always a guarantee. Like, there's no guidance on how to build subscriptions into your GraphQL server. And so that's something that requires a little bit of forethought, a little bit of planning. And so when it comes to Hasura, you get subscriptions right away out of the box, auto-generated with your data. So a real-time API on your Postgres database or what have you is a really powerful premise. So then what are these subscriptions? Subscriptions, let's have a look at a traditional, stack that you might have built or certainly have interfaced with before. You've got your API layer that's between you and the client, and you have a database that is essentially writing all of these snapshots into. Then you have a bunch of other microservices, hopefully, that are being coordinated at the API layer. And so it's kind of like coordination to my microservices, and then over to the database, and then back to the microservices, and a little update with the client, and then back and forth. So you have this system that is relying very heavily on a hopefully a robust but a very strategic and very important thin layer, and that is your API layer. That if you're writing all that code yourself, you've got a lot of opportunities for failure. It's very complex. And as soon as you've added enough complexity, nobody's going to touch that. Nobody wants to iterate on that. And it's a let's rebuild and not actually try to update that API layer. And this is an API conference, so you know exactly what I'm talking about in that regard. So subscriptions help us switch to a different paradigm that's often used in programming, and it's sort of the event-driven architecture that you probably are quite familiar with at this point. And that is where you have then this database data layer that then is triggering events based off of CRUD behavior. So based off of server state, on CRUD behavior, it's triggering these events to the actual microservices. So payment processing, restaurant approval, whatever your domain is. And then you're getting real-time updates whenever that data set updates. So that allows for full async operations inside of your ecosystem. So you may have a longer time for payment processing, or you may be having a really long, like incremental update for delivery from food processing or something. And that process, that phase, is something where getting those real-time subscriptions where the client is able to actually be listening itself for updates and have a persistent handshake with your data set, where you're getting these signals over WebSockets, typically is how it's mostly delivered today. That is a very, very powerful concept for application development. The reason why it's not what everybody is doing is because it's challenging to write, and it's challenging to write WebSocket support, and it's challenging to create this, coordinated data layer where you're able to get access to the real-time events and the eventing. And that's what Hasura is solving for, is it's giving you that out of the box. But the subscriptions are specifically this communication between the data layer or database, what have you, and your client. And that is a WebSocket handshake that is then pushing updates. And we're going to kind of do some more examples here to see just what this actually looks like. So if you'll take, for example, the typical use case of a, let's say, kind of a pub sub sort of relationship. You've made a subscription subscriptions. This is the typical approach you would have. The way it is today is you would have a subscription on your database for a specific order, right? So you say, I want my order, and I want to know, like, when's that pizza arriving, okay? And so you're going to get, at each incremental phase of the process, you're going to get a new message that is going to be the current state of that object you're watching. So a subscription is watching a specific record, and it's getting, and we refer to this as a live query, where it's essentially rerunning every time something updates on the server. So I'm watching for this specific record, and there was a database event. That database event triggers a WebSocket message to my client that's listening, and it says, okay, here's the current state, everything, like all the data you have. So current position, current location is XXX. Next location is YYY. The next location is ZZZ. But you're always getting the full snapshot of that query with each message. And that is actually what you want, like in a lot of cases. So anything where you're observing state, anything where you're observing like the current status of a thing, that's what you want. Like, is you want to have the whole state where you come back. This is really performant. This is a great way to be able to work. You're getting the absolute truth from the server every time. There are cases, however, and you know, this, I just want to actually add some additional detail. I mean, this is actually a very effective and a performant like solution, right? So scaling to millions of live queries, you're getting very, very low taxation on your actual CPU. Like this is real numbers from Hasura, you know, running in production for somebody. And this is kind of the architecture you can do. You can scale this horizontally. So you can literally have 1 million rows updated per second. We have customers doing this, and delivering unique subscriptions to every single individual client for the status of their thing. Think scoreboards, think food delivery. I mean, that's very pandemic relevant. Think all these different statuses where you want those kind of updates. This is a very powerful solution. We have a customer who actually was able to replace a Shopify stack in 4 weeks with lower costs and lower man hours, using this exact paradigm of, you know, tracking shipments, tracking deliveries, all of that. Like it was an amazing performance. But here in this diagram is actually where the issue of streaming subscriptions starts to surface, right? So we have a very specific thing that we can see here. And if you haven't noticed it yet, I'm going to go ahead and highlight it. And that is, so the 1 million rows updated per second. Okay. If I'm subscribing to one of those rows, I don't have a problem. Like that's fine. I don't care about your other like 999,000 records. I just want my one, and that's fine. I get one record, and it's a small payload. But what if I'm more like an admin, or what if I'm needing to have something that's more like an event, or I'm actually watching order events coming in? Well, then for each of those events, I'm getting that live query, right? So I'm getting the full payload with each update. And well, you know, servers have limits. For as awesome as Hasura is, you know, there's hard caps on how many responses you can actually get before you just crash your server. And so you can see this in the abstracted example here. If I get order 1, order 2, order 3 now, and then scaling that on down to how many orders are coming in, well, now I've got an actual major issue, and that is because the payload will eventually and quickly become simply way too problematic, and that's a thing that happens a lot when it comes to doing subscriptions for events. And so that brings us to this next paradigm here, and I'm going to allow Karthik to explain a little bit about what's happening with streams here.
Yeah, hey, sure. As Jesse showed, I think the subscription feature is really cool with the libraries itself, but it's not very efficient. For example, let's consider this case. So we have a page, and we have to show all the orders. And hey, Jesse, could you go one slide before?
Go back.
Yeah, yeah. So let's say we are rendering the all the orders using this subscription query. So we'll go. So T1, T2, T3 are different timestamps. Uh, when we start, we'll start with one order, and as soon as the second order is added, we'll get a new response in our client, and we'll replace the whole whole response we got. In this way, we don't have the client doesn't have to maintain any state, but as we can see that we are sending the order one data again, and in T3 we are sending the order one and order two data, which is already there in the client. So what how can we better make how can we better this? Hey, Jesse, could you go one slide? Yeah. Okay, so we thought about this. So we introduced the concept of streaming. So streaming is we'll get only the data we need. Uh, so in this case, we have the data. We start with order stream one, the first order, and as soon as the second order uh, is placed, we'll only get the data of that order. We won't get the data of the first order again. And uh, similarly with the T3 thing, we'll just get the order with just get the data of the third order. So uh, so uh, i mean it doesn't seem much of a difference, but the thing is, we don't send redundant data back. So there's not much data to be fetched from the server and to be sent to the client. We just send the required data back to the client. Okay, okay. Currently, the way this subscription stream works is you'll have to choose a cursor upon which the streaming would work on. This so you'll so currently we support column based cursor. So you'll have to choose one any column of your table as a cursor. So the a generally good choice of a cursor is the timestamp. So you can say that I'd like to start my streaming subscription with this timestamp. I want all the data which happens after this timestamp. So the cursor is a very important part of the streaming subscriptions. Okay, so and this is the benefits and the use cases. So when we started making this, so initially we wanted to make an MVP of the streaming subscription to see if it works or not, if it is usable in the real world production. Uh, so so the initial use case was to to make streaming subscriptions to fetch large amounts of data. So one of our clients had this use case. So they wanted to stream millions of rows. Uh, but they were so as we all know that streaming is generally a very very difficult problem to solve. So we gave it a shot. So we tried to make use of the subscription code we already have. We just made some tweaks to make this streaming subscription. In this what you can do is that so in this so fetching large amount of data is uh, is one use case. And let's say we have a messaging application, um, and we are seeing the messages of a particular channel. So if you use the live query subscription, so every time there's a new message, you'll have to fetch all the messages of that channel whenever a new message comes. But if you are using streams, you can set the cursor as the created at of the messages. So in this way you'll only get those messages which aren't already read by the client. So and it's also really helpful with IoT streams, so that you'll only get the data you actually need in the client. Could you go next? Okay, if so, all Hasura users know that Hasura provides authorization and relationships, and this coupled with streams. So the problem with streams is the streams problem itself is very hard. That authorization on top of it is very difficult, and relationships are quite difficult. And also now since these are GraphQL subscription streams, you can precisely choose the data you'd want. Like if you want only two columns, or if you only want two columns out of all the columns of the table you have, then fine, you can only specify those. uh, so so and relationships. So relationships is Hasura's way of telling that is Hasura's way of telling that is joining of different tables. So you can join different tables in one query and get the results of those using subscriptions. Yeah, next. Okay, so streaming subscriptions is something we have started very recently, and it is still in active development. But there should be a beta or alpha release soon. So there are some gotchas here. So currently we are only supporting single column cursor. I mean, we have plans to support multiple column cursor, but yeah, for now, just a single column cursor. And the cursor you choose should be sortable. Um, that is, I mean, there is no restrictions the by the by Hasura. You can use any column as your cursor, but it will be most effective when the columns of a sortable manner. So in the image, as you see, so the first column is an integer column which is ever increasing. So this will be a good choice. The so and the second column is a boolean, which is not a good choice because there are only two possible values. So you'll get now if you choose your cursor column as true, then you'll only get the false values, and yeah, that'll be it. So it's not a good choice of a cursor column. And the third column is a timestamp, and which is also a really good choice of a cursor column. uh, okay, so this is it. And there's no back pressure support yet, but we do plan to do on it. So I'll explain back pressure here to folks who might not be aware of it. So um, currently the server keeps on sending messages as soon as it generates, and the client keeps on processing it. And suppose if the client is not able to keep up with the server's message generation, so there's no way of the client letting the server know that, hey, could you slow down a bit, because I already have a huge backload to process, and I'll not be able to process more. So currently there's no way of knowing. So the server will keep on generating messages, um, and the server has currently no way of knowing that a client is overwhelmed or not. Okay. uh, but we do plan to add some support to it in the future. Yeah. Thanks.
Yeah. So if you're familiar with the GraphQL spec, or you've looked at streaming or heard a little bit about streaming, in the community, you're probably wondering what's related to then the @stream directive that is currently in RFC for the latest version of the GraphQL specification. And the primary thing is that they're totally different. Well, maybe not totally different. Karthik, do you have a comment on where the stream at stream versus our stream implementation differ?
Yeah, I'll give some background on the AppStream directive. So the GraphQL community has come up with these two directives, the AppStream and the add_defer. I'll not be talking about add_defer, but I'll be only talking about the AppStream directive. So AppStream is a way to get the data if the server already has it, even though it's not the whole result set. We are even fine with the partial result if the server has ready. So this is the this is a streaming, and the @stream, it works on queries as well. Not like a Hasura streaming subscription, which is only supported with subscriptions. And The difference, the main difference is that the @stream uses HTTP to transfer the data, and the streaming subscriptions used by Hasura uses WebSockets, and the @stream directive, it uses the HTTP transfer chunking encoding, which is relatively new, and there aren't many clients which support it, and but you could still use streaming subscriptions because there's pretty good support for WebSockets. Yeah, and yeah, I think this is it. Yeah, so this is what I explained basically. Yeah. Okay, so streaming subscriptions are, if you're thinking about why should we consider streaming subscription. You're getting streaming with Hasura, that is pretty cool, and it is easier to use by any client. This feedback was given by one of our large scale client. So you don't have to fetch all the data, unlike the live query subscriptions. You'll just fetch the data which is relevant for you, and you get authorization relationships out of the box. So that's pretty cool, and it is more performant because we send only the relevant data to the client. Yeah.
Yeah, so that brings us to an opportunity for you to be able to actually test this out. I will drop this link as well inside of the chat. This is going to be something that you'll be able to test out the subscriptions version on Docker. And there is a render. If you're not familiar with render, it's a deployment platform, but there is a render YAML file in there that you can basically just clone the repo and be able to deploy a working example of that. This is the open source version of Hasura. But that's basically if you wanted to kind of get started in terms of next steps, just personally. So have a play around with the actual stream directive. Not directive, but the stream method. I've been talking too much today. And there's a number of really good libraries out there that they provide good support for this stuff as well. So if you want to try out with subscriptions or work with them, Apollo GraphQL obviously is great for subscriptions. React Query is kind of the one that I'm really into these days that works really well. GraphQL Zeus, GraphQL Cogen, GraphQL WS, the last two actually being projects from the Guild. Are all really great ways to work with subscriptions or work with clients that'll be able to help you handle subscriptions. Those are more front-end specific. There are back-end utilities as well. I'm a front-ender, so that's kind of where my familiarity sort of ends with that. But basically, I wanted to then switch to demo mode and be able to show a little bit of how this kind of looks or works. And just, yeah, it's a little funny, but but we're gonna have fun with it. So I'm going to switch off my slides now and be able to use the actual browser here so that we can have a look. So what we have for the first part of this demo here, I'm going to drop I'm going to show you the example here, and I'm going to drop the URL in a minute. So what we have here is a very basic building. We were having an argument earlier, and you'll see why in a little bit. This is not cake. This is actually a building. But this is a really special building, and the idea of this example here is that you could imagine that you are an admin of some kind, and maybe you're needing to track the status of which lights are on in the building. Maybe this is an office building, or you are trying to see like who left lights on, or is there activity happening in a certain room, something of this kind of abstracted nature that developer relations like to belabor. So we have two different subscriptions happening here though, right? So I'm going to go ahead and turn on some lights here. And as I turn them on, you're going to see that there is a couple of things happening here. So in the right-hand side, I'm getting individual events. And if I go ahead and actually toggle one of these lights over and over, we'll see that I'm actually stacking those events inside of the actual browser here. And that's a stream of events for the specific things happening, the specific actions. And in this case, if this had been a live query, I would be just replacing that state. Now, the building itself, though, that is actually a state, a live query for the visual state of the building. And this one, and when I'm getting this, I don't want to stack up like the current status of the lights and things. I want to be able to just get the current snapshot of the building as is. And you'll see a little bit in some of this performance. And we have some, this is a alpha preview. So we'll see how well the stream's hold up here. I'm going to drop this link now inside of the chat. And if you go to this link and have a play, you'll see that if you click on some of these actual layers on the building itself, you're going to see where the cake argument came into play. But what's going to happen is that all of these clients will be mutating the data directly on the database through the data API layer. And then that data API layer is going to send a subscription to all of the connected clients about what's happening. So nobody's doing it yet. Somebody's got to click on something here. We're gonna wait till somebody in the audience clicks on something. I saw a light switch. And then if we click on things like the actual layers of the building, so if I were to click on, say, this one here or that one, we'll start getting some fun things going here. So we'll let the subscription party begin now. But you'll see how this would then become really handy, because a lot of different clients are updating things real time. So the building state, we're getting a very performant, very fast snapshot of what's happening. And then we're getting a very lean stream of events that's coming in from the actual system. And it looks like my system has gotten a little bit crashed. There's a little bug where one of you will actually be getting the stream of events in your browser. That happens right now. It's a little funny thing. So kind of like the last person to connect starts getting the streams. Again, it's a preview, but the functionality works really well, and it doesn't work really well sending it to a giant conference of people to click on. But so it's a really cool way to be able to work, because to set this up, though, it's a really lean architecture. So let's have a quick look here. I'm going to take you all into a little bit of React land, which I apologize for if you're not React people. But let's have a quick look at what we're actually viewing here. And I'm going to open this up inside of a code space, actually. In fact, I think I'm going to skip the code space, and I want to just open up the code editor that I have, because I think that's going to be probably even more performant. So let's just have a look here at what we're actually working with. And I want to boost my font size here so we can kind of have a view around. And I'm just going to close down all these windows so we can kind of look around a little bit at what we got here. So if you look at the code base, if you're not familiar with React high level, it's just a front end client that essentially maps a couple of component architecture, if you're not familiar with that paradigm. I think that most people at this point are probably familiar with a little bit of how React works. But so essentially, all I've had to do is, I've written this page that has a state watcher at the top of it that's looking for updates to the changes happening inside of the application locally, and then I've just initiated a subscription. And if we look at that subscription itself, we can come in here and actually see what's happening. So I'm telling this to use React's paradigm to say, once everything's loaded on the page, go ahead and trigger this off. But what's happening is I'm using just a simple WebSocket where I initiate a connection. And once I initiate that connection, then I just send a subscription straight to Hasura. And that subscription then basically just has a on message event, and it's listening for anything that happens inside of my data set. And as soon as that data set happens, it's just updating my local state representation of server state. This is using React Query specifically. I think this is one of the reasons why I really like React Queries, because it has a paradigm where it focuses on the idea of mapping server state as the representation of what local state should be. So all of your mutations and behaviors are actions against the server, and then the server sends updates back, or you're able to trigger manual fetches again and be able to update. And that triggering of manual updates is worth noting that in a lot of cases, you might even be able to bypass the need for subscriptions altogether, because it's a really important first question to ask is, do you need subscriptions? Because in some cases, triggering another fetch is as strong and robust as a subscription would be. But this allows us to be able to work with this sort of concept where we're fetching the data, listening to events, and then we're simply just updating this global snapshot. So in this case, where it says query client, let me go ahead and close down the side there so it's a bit easier to view. From here, it's just saying local state. As soon as you get the snapshot back, this building payload, just go ahead and replace what you have on page with the building snapshot. So this is the idea of a live query: is I get the snapshot from the server, place it in my state, and I'm totally replacing everything local. But that's different is when I'm using something like the light switch one here. So I'm going to go to the light switch subscription. Same thing again here basically happening is I've got the subscription where I'm in this case using a room light stream in my query. And I'm giving it the cursor to watch, which is in my case, I'm using a timestamp. And don't do string concatenation on your GraphQL queries. Just that's only allowed for developer relations people. You should use payloads. But I'm just going to add that. And so what's happening here, though, is when I get this stream data back, though, I'm pushing that data onto my array. Also, don't put console logs in your production code. That's only something developer relations are allowed to do as well. But I'm pushing that new data into the stack of the old data, and this is how streams then work, are meant to work. Is I'm updating this, like I'm getting a new thing, one thing at a time. I'm pumping it inside of my list that I'm then iterating over on my client code. So this is basically the behavior of kind of how these two different things work. But so I've got these two subscriptions, okay, a little bit of fancy code, but essentially you write it once. This is WebSocket code to just create a connection. WebSocket could do a bit better in terms of creating nicer client libraries, but here we are. So we'll accept the magic for now. So I got two little WebSocket utilities. They're essentially 99.9% identical, except for the query that I wrote and what I do with the response. And then in terms of as a developer, I'm able to just simply go in here into something like my components here. And I have, on the floor click where you're, changing the color in such pretty ways. The actual floor component, it's literally just one mutation. It's just one function here that as soon as I click on the floor, I'm just updating just the color of the floor. Just bloop, bloop. Like I don't have to do more architecture. I don't have to do more management or anything else, or even manage something else on the server. With Hasura, I've been able to lock this down so that this is essentially just giving everybody the ability to update that one field in Hasura, and I made that then public, and I don't have any concern with that in this case because I'm not. I trust you all. You're not going to just go out there and DDoS my server. But I've been able to lock that down and just say, okay, in this one case, I only want this one column to be updated, And that one column is enough to then trigger like an updated app behavior on the actual database side. And I'm watching that with my subscription for a read layer. I'm not letting you change that with mutations. I'm watching that on a read layer and then updating based off of that event. So something local, again, very thin architecture, very, very mild. And I was able to put this demo together in about an hour. It's like, this is just incredible power you have with Hasura these days. Let's have a look again at the current state of our cake building. Ooh, nice. You guys got some good artistic talents. I like it. And we can, turn some things off. We can go ahead and reconnect things and play around with it. So a lot of fun. It's always a little bit nervous when you allow an audience the ability to draw on your screen. So appreciate you all being well behaved with that. And so let's have a quick look then at sort of how this is happening under the hood from the Hasura side. So I'm gonna drop these demos here real quick into the client so you can kind of poke around and maybe spur some questions if you have. Here is the actual front end application, and here is the one that I dropped earlier, I think, but I'll drop it again here just in case. That is the one that gives you the Hasura instance. That is a open API, the one that you would grab there. If you need, you can look up adding the Hasura admin secret as an environment variable. That's something that you can look up on Hasura docs really easy, but that's just something to bear in mind, is that's a open project. Mine's locked down, so don't even try. So we're going to go ahead and switch over to looking at the actual Hasura interface here a little bit. So this is what you get when you actually come into Hasura, is you have data API, data layer kind of functionality behavior, and so you've got the current version you're running. You got the API here, which is using GraphQL, which is a kind of the standard introspect the query kind of utility that everybody uses. And I'm able to use that to explore around here. I'm able to come in here and say, okay, what other data do I have? I can grab maybe the floor aggregate or something and be able to get like a count of how many floors this building actually has. And I can do all kinds of cool things here. I can go ahead and fetch this data. But what's really important, especially when it comes to streaming, is I'm able to use this as my utility for debugging, right? Because I want to come in here now and I want to run a subscription on this, and I'm going to do something just kind of like get lights, and I'll do a subscription on the actual room lights. Let's see your room. What do they call it? Like, and this is where it's also really great because you get that autocomplete, that tells you what you named things. So I'm going to go ahead and say grab the room light itself, stream, and that's the specific denotation we have for stream for watching the streams on those rows. And now I need to pass in a couple of important pieces here. So I'm going to go ahead and give it a batch size of, I don't know, maybe 5. And then I'm going to give it the cursor is going to be watching the
updated
it's going to be my updated at, and then I'm going to
you'll provide an initial value.
Yeah?
You'll provide an initial value of the updated at.
I need to provide a value, you're saying?
Yeah.
I hear, right?
Yes.
Yeah. So I'm going to just put one really simple on here using Postgres here for today. And then I'm going to go ahead and add a other one here, and that is going to be the order. Well, the order is going to be default ended. So
yeah.
But we don't need much more than that. And here I'm going to go ahead and just grab the status of the light. I'm going to grab, and because we have relationships, and this is something that you can't really do with things like Kafka or Rabbit very easily anyways, is you're able to get the relationships here. I want to know which building these lights belong to. So I can go ahead and move one up to the room. I can move one up to the floor. This is all GraphQL relationships here that I get free out of the box. And then I can go up to the building. And then I'm going to just grab that the name of the building here. If I get called it slug actually. So if I run that subscription, then you'll see, as people are playing around, that there will be a updating of the stream, and it'll be updating data. So if we come to the actual demo here, and I pull that off screen here a little bit for reasons, then we should be able to get the updating if I haven't crashed my or overloaded my cheap stack here. Maybe I've overloaded my stack, but when you're not stress testing your API in public on a on a conference stage, what you do get is you get the ability here. I'm going to try and grab a Unix timestamp here real quick and just see if I can sort of fudge this real quick.
Meanwhile, if I'd like to explain how this works.
Yeah.
In background. Okay, so as we see here, there's this room light stream subscription we are running, and there's this cursor we are provided the updated ad. So the first the first time this runs, we are trying to get all the trying to get all the lights which are greater than the mentioned updated at. And suppose we get some results from the server. We'll in the server the last we maintain the last updated at. So if we are sending like five rows in one batch, so we'll store the last value of the updated at, and in the next time the GraphQL engine pulls for this subscription, it will be based on that updated. Now let's say the last updated at is 12:09 at 12:55, and let's say then we get some data, and the greatest updated at value there is, so let's say 13:55. So the next time the subscription returns any data, it will be greater than 13:55. So you won't get the data which the server has already sent.
Yeah. So it's not stacking a queue for things that it's already delivered. It's kind of like for those of us in the pandemic world, if you've been on a Google chat and somebody drops a link in the Google chat before somebody's joined, it's not there for everybody else to be able to access anymore. It's kind of like that. So yeah, this is working now. I think I just didn't have a great comparison operator for my updated at, so my bad. If you click around now, you'll see that we're able to track the behavior of the tree, and get all the data that we're looking for. So pretty fun stuff. So this is really powerful though, right? Because when you need to debug, how are my subscriptions working? Am I getting what I'm expecting? Permissions wise, here this is read, so I should have access to this, right? So if I turn this off, the secret, then everything's still going to work just fine. But if I were to try to maybe access an operation that I don't have here, that I thought I should be able to do from the client, and I maybe say something like insert, if I want to say insert YAL, I don't even get the autocomplete because there's no introspection. So if I have a mutation here that I don't actually have, so insert building, and I do something kind of like just this real quick, and I need to give it a slug, and I give it a return on this. So like this is valid unless I remove my authentication, right? And then it's going to complain to me, say, no, that's like, I have no idea what you're talking about, insert building, and that doesn't exist in your API, because this is part of how the permissions control work. Now, if I were to allow for inserting buildings, I could come inside of the actual data model here, go to buildings, and go down to the permissions. And for the anonymous role that I've enabled, I could actually go to insert only, and I don't want to allow inserting on things like or like deleting, for example. I could say, yeah, I'm going to go ahead and allow, without any custom checks from environment variables or anything, I'm going to allow people to insert just the slug. They can't, modify the ID. They can't do the created at or updated at. The database will pre-populate all three of those. but they can go ahead and make inserts on the slug. Then if I go back to the API Explorer, then it'll actually say, yeah, no problem. You can totally do that. So this is that lockdown approach where you're able to have very fine-tuned controls, like right on a specific column through a couple of clicks, and now I could deploy this specifically to production. And using, I'm gonna take this example a little further because I still have a few minutes here. If I go ahead and I say something like, call it a create building mutation.
Hey, no space.
I'm going to go ahead.
No space, yeah.
I'm going to go ahead and go back out to my code here, and I'm going to show off a little bit of what makes the guild so awesome. If I go to something like my queries, which is where I'm saving all of my actual documents, let me close down components here, and I go to the queries here, I make a new document that I'm going to call something like create building. GraphQL. But here I can write, I can take that same query that I tested inside of Hasura, that I've proved that my permissions are correct and everything's correct. I'm going to go ahead and parameterize this real fast because that's the smarter way to work. So if I say something like slug is going to be a type string, then I'm going to go ahead and pass this in here. Now what I can do is I can come into my terminal and I can actually generate utilities around that. So I can say something like yarn CodeGen, which is a utility that I've already set up. And this is all available to you inside of that tool. I've now generated utilities that actually allow me to be able to work with this. So I can come inside of something like the index here. And I'm going to go ahead and say yarn dev. And if I were to be working with if I wanted to create like an import for accessing, inserting a new button, I can come in here to this generated bit of code up here, and I could import something like use create building mutation. And now if you're a React person, I've got a free hook right here that I'm able to work with. And say something like const, create building equals. And now I have a authenticated CRUD enabled utility, a function there that'll actually write data. It'll trigger subscriptions directly in my server. Now I'm not going to do it because my code's brittle. and the live version and my local version are pointing to the same endpoint at the moment. So what I don't want to do is to actually mess with the UI and break things, make it look weird. I can show you where I did this just before this actual talk today. I created a reset button though, using the same approach. So use reset room mutation. And what that does is it sets everything back to a black building with turned off lights. And so you can have this button here that just on click runs the mutation that you pull off of this hook, and it resets the building. So if we were to take the live URL here, and I go /reset on that, and then if I push that reset button, it'll actually reset the building back to a blank slate. So I'm sorry if I've ruined somebody's 10-minute art there that they were meticulously hoping that random color would finish the mosaic. So it's a really, really powerful way to work when you're able to leverage the GraphQL spec. So you're able to leverage the introspected queries. You're able to leverage the type safe utilities and functionalities into the code. You're able to leverage tools like Hasura that give you an instant GraphQL API on your database. And you're able to then access, fine-grained permissions. You're able to access subscriptions, and now with subscriptions with stream support. And you're able to just really build so many different use cases that before would have been really, really challenging or take a long time to work. And it's a really powerful way to actually be able to work with your data and shipping products to production. That's my whirlwind demo part. Karthik, do you have anything you want to add to that?
No. I think I'm good.
I did want to mention, I did see one question in the audience, so I'm going to answer that right now together while we're at it. If we can get my slides back on the page just for a second. There was a question about with subscriptions, what do you do if you need to actually get heavy amounts of data transform back? So what you could do, so you could use something like Actions, which allows you to create a custom resolver that executes your data, and then you can basically you'd have a new field in your top level API that would be something like, I don't know, reset data, for example, and I would abstract all of the code into there. That doesn't give you subscriptions on Actions at the moment anyways. But what you could do is you could definitely have a new table that would be something like a transformed data table. And you could have an action that would then be utilizing the data that you're needing to transform, that would then write that into your transform table or into a custom view. Even if you could have a custom view because there's Postgres under the hood. Not even under the hood, like it's just Postgres. Then you'd be able to do a subscription on that view and be able to actually pull in the data that you needed to maybe in a pre-transformed state and use that action to mutate or update content that you're then watching. So there's a number of ways to work around the paradigms that come up in most any use case. But I think that gets my throat back a little bit. I'm just about to lose it in the coughing here. That would be one way that you could solve that specific problem. So with that, we can throw my slides off the page. I think that takes us up to the end here. I'm going to say thank you to Karthik so much for coming in. And did you lose power during the talk?
Oh, me?
Yeah.
Oh no, I just forgot on the light.
Oh, it's all good. Sometimes that happens when we're having meetings. It's like, there it goes. But I really appreciate you coming in and really short notice too, joining me and showing off what you've been working on. Really, really great. And I think that creativity like that in the future, like, is where GraphQL needs to be able to kind of push to solve more and more use cases. So really, really appreciate you coming in and joining today.
Hey, just want to add, if any of the audience members are interested in the feature, they can follow Hasura's Twitter account. Will be making the PR as public, so the folks can try it out and give feedback, and we can improve the feature as soon as possible.
For sure. Cool. All right. Thanks.